Hello students, you are welcome to sirMATHS. Today we are going to discuss simple equations, and that is as it concerns grade 7, equivalent to JSS 1. Simple equation. Simple equation consists of one variable, one unknown, and the power of that unknown must be 1. That is simple equation. It may not be written as 1. We have first degree, second degree, third degree, and so on in mathematics. When we have x raised to power 2, that is second degree, a raised to power 3, that is third degree. But when we are talking of simple equation, it is raised to power 1, and we don't write that very 1. When there is a variable without power, automatically it's raised to power 1. When you just have something like here, x, without any power written, it is automatically raised to power 1. And so in our simple equation, we will involve variable of first degree, that is variable of raised to power 1. That is what we'll be treating in this simple equation. You discover it is what you have been applying in life, that there is nothing serious about it. Now let's all have this. You expected to say whether that is, you just say true or false. That is in the following question. Number 1, you expected to say if it is true or false when we have this box minus 8 equals to 5, and that is when 13 goes in the box. When we put 13 here, will it make this statement, this equation to be true? Will it be true or false? What you do, you first of all solve to find out. You now say 13 minus 8. What is it? Is it 5? Yes, 13 minus 8 is 5. So you now say your answer to this question is it is true. That is your answer. Because 13, as we are given here, 13 minus 8 is 5. Example 2. You are still expected to say if it is true or false when you have 11 plus box. Is it equals to 15? That is when 26 goes in the box. You now solve to confirm before you say true or false. You have 11 plus, we are told that 26 goes into the box, plus 26. Is it equals to 15? No. 11 plus 26 will give us 37. So your answer here is false. It's not true. It's false. We are using these variables as a variable, as unknown. And you can see that each one of these is just one step. This solution is just one step. Number 3, box divided by 8 equals to 4. When 2 goes in the box, you solve 2 for the box over 8. Is it equal to 4? No. 2 over 8 is 1 over 4 and not 4. So your answer here is false. Because 2 over 8 is not 4. It's not. Still one step. What about number 4? 19 times 2 equals to box when 38 goes in the box. Two times 9 is 18. 8 carry 1. 2 times 1 is 2. 2 plus 1, 38. So your answer here is true. It is true. Well, talking of a simple equation, so this is true. I do hope you are following. That is, when we expected to say true or false, we have done that. Let us go into further simple equation. Here we expected to solve. When you are asked to solve, it means find the value of the unknown in that question. Find the value of the unknown in that question. Let's have this example. 7x equals to 28. Let's label this number 5. So with this very word solve, we expected to find the value of x, not 7x. And so we now have 7x we are given divided by 7, because we want to single out x, which is what we are looking for. And what you do to the left, you also do it to the right. We divided left by 7, we must divide right by 7. And of course, 7 cancels 7. We have now singled out x, and 28 divided by 7 will give us 4. We have solved. We have found the value of that variable, that unknown before is now known to be 4. Simple equation. More example to this effect. Now, what of number 6, where we are 1 over 3y is equal to 4. 1 over 3y is equal to 4. 1 over 3y is the same thing as 1 times y is y over 3 equals to 4. In principle, over 1. I hope you still remember that anything divided by 1 remains the same thing. I just said in principle over 1 so that it will just look like fraction, just as the left-hand side. At this point, you cross multiply. You cross multiply. You now say y times 1 is y equal to 3 times 4 is 12. We have found the value of this unknown, the variable y, and it is 12. I hope we all are following. We have more examples. We are given m minus 1, number 7. M minus 1 equals to 6. We simply say m minus 1. We want to remove everything with m so that m will be alone, because it's what we are looking for. We are finding the value of m. And so since to remove this minus 1, we have to add 1. And what we do to the left, we must do it to the right. Why did we add 1? Because we know 1 minus 1 will be 0. So m now will be alone. It will be singled out. So we now have m, because 1 minus 1 is 0. And 6 plus 1 is 7. So m is 7 in this very particular question. We go on, number 8. We have here 32 equals to 8q. So we expected to find the value of q. And that is 8q. We divide it by 8. We're looking for q. What we do to this side, we must also do it here to retain the equality sign. If you do anything one side and don't do it the other side, then this equality sign will now be destroyed. It will no longer be equal. So what you do to the left, you must do it to the right. And so the 8 cancel 8, and 32 divided by 8 will give us 4. So we have solved that. This is a simple equation where we just find the ungiven, or rather we find the variable, the unknown. We just find it, and that is simple equation. We find that depending on the nature of the question. Remember, we started with a box. That box is used for variable. We were asked to find if it is true or false when we are given the what should be in the box, and so on and so forth. It's possible also to give us a question. Let's call it number 9. You say box plus 8 equals to 17. Then here we expected to find what the box is all about. What should be in the box? You simply say that the box plus 8, you remove this 8 minus 8 is equals to 17. What you do to the left, you do to the right. And so 8 minus 8 is 0. So box is singled out, we are looking for. 17 minus 8 will give us 9. We have found the value of that very box. This is our simple equation. I encourage you to go and solve more, applying this principle we have done here in this simple equation. Don't forget to subscribe to sirMATHS to follow us along in this wonderful and exciting journey in the mathematics world. It is an interesting one. Thank you for joining us today, and we wish you continue joining us. In our next meeting, we'll discuss something different from this. There must be a progress. So thank you again for participating. We call it a day.